All right, let's answer the last question, right? What is its speed when it's very far away? So let's look at this thing, right? In our first frame here, this thing is flying directly toward that charge, right? And we answered the question, when it's 1 meter away, it's going 12.5 meters per second. It'll get as close as a little closer than 1 meter, right? But then the next thing it's going to do is maybe it's just gone, right? It's going to go flying out here. And so we want to know how fast it is going later when it's farther away. Now, by the way, this answer will be exactly the same answer as what velocity did it have to have when it was far away, so that when it got 2 meters away, it was going 34 meters per second, right? So this is a higher velocity because as it approaches this other charge, it's going to slow down, slow down, slow down, slow down, stops, and it goes back this way. Okay, so whatever that speed is that we figure out that it subsequently gets is also the speed it had to even do this in the first place. Okay, so let's figure that out, right? What we're going to do is we're going to set this total energy here, which is potential and kinetic, equal to this. It has only kinetic energy there, right? So our K times Q1, Q2 over R, in this case is 2 meters, right, is just simply going to equal the kinetic energy here, right? Because it doesn't have at infinity, right, the potential energy is KQ, Q over infinity, right? So that's 0, okay? Oh, I forgot, it's got kinetic too, right? So 1/2 mv squared. Here it's moving and it has potential, and then that turns into just kinetic energy. Okay, so let's see what this does here. I'm going to go K times 160, E minus 6 times 160, E minus 6 divided by 2 plus 1/2 0.23 times 34 squared. So that's the total energy it's got at this situation, right? And then in this situation, it's going to be just kinetic energy because it has no potential. It's infinitely far away, right? So this is just going to be 1/2 0.23 v squared, and that's what we're solving for, is how fast is it going, right? Okay. All right, so let's figure it out. This term here, that first term is, what is that first term? We can do it. Let's see, where is it? There it is, there. That is 115.072. And then this guy, 1/2 times 0.23 times 34 squared is, that is 132.94. And then that equals 1/2 0.23 times v squared. Okay, we can do this. Let's see, I'm going to add those two. That guy plus that guy. 248.012 is 1/2 0.23 v squared. Okay, so times 2 divided by 0.23. That's v squared. Take the square root of that, and you get 46.439. meters per second when it's very far away, right? All right.